Really quite an impressive gathering. I'm really happy to be here, and I'm really glad that you guys are here. And Dee is absolutely right. This is going to be a great evening, very entertaining. Entrepreneurship is a fascinating human activity that stretches across all types of societies. It combines ingenuity with risk-taking and confidence and faith in the future to build jobs for personal gain and for public gain. So it's an incredibly interesting activity. I think it's all over the news these days as well. I mean, we're seeing these valuations on Twitter and Facebook that are way in the billions. Snapchat refusing offers for $3 billion from Facebook. But there are plenty of other inventions that are not nearly so lofty as these that are still incredibly useful and are used by people all the time. And I think Shark Tank is such a popular show because it shows how ordinary people can take their ideas and turn them into very, very useful products for people and society and making jobs. So we are really pleased that we are able to run this competition. We've been involved here at the Moore School with entrepreneurs and development of entrepreneurship for many
Okay, so we move on now to the FCRA Technology Ventures Technology category. And our first finalist, Sage Energy Solutions, and is represented by Kai Manyaga, a sixth-year chemical engineering graduate student, and Sun Tak Kim, a fourth-year chemical engineering graduate student. Kai?
Hello everyone, my name is Kai Maeda and I'm a graduate student in the Chemical Engineering Department. And I want to talk to you about our startup company, Sage Energy Solutions. I'm going to start by thinking about the problem if you consider NATO forces. In particular, there are 28 member countries, and of course the US military is one of the largest contributors. Now let's look at a NATO soldier. So tonight we'll call him Kaki. So Kaki knows for any military operation he needs to go to, he needs his equipment, his food, and his energy for his devices. And it's this energy part that really bugs us. Especially when you consider that for a 3-day mission, he needs to carry 50 pounds of batteries. 50 pounds. That's a lot of weight for 3 days. And what this 50 pounds does is it reduces his mobility, it reduces his ability to carry out other pieces of equipment which may make him safer or more effective, and it obviously just reduces how much things he can do in the field. So this 50 pounds of batteries can be shaved down to 5 pounds with something called a fuel cell. Problem solved. Done. We don't need to do anything else. Well, not really. The real problem is that the fuel cells that the military are interested in uses propane. This is the same propane that you use in your gas grills, widely available, cheap to buy, easy to store and transport. Let's just ship it in. We are the US military. But the real problem is that propane is not available in the battlefield. And the reason is because if you take a look at a map of Afghanistan, attacks on the US military are primarily centered around convoy routes. So just ship it in is not nearly as easy as said as done. I'm sorry, not nearly done as said. And what they only have access to is NATO jet fuel. And they ship this in with all of the devices. So obviously they use it for their jets, but less obviously they use it for their Humvees, their tanks, their M1s and whatnot. So the question now becomes, can we use jet fuel to somehow enable these energy-dense devices called fuel cells? Well, in comes Sage Energy Solutions to the rescue. We've got a nanomaterial that our CTO here designed and synthesized. He calls it platinum gadolinium TSM5, and for the rest of us mere mortals, we call it fairy dust. And the fairy dust is what we're building our entire company off of. What we can do is we can catalyze a reaction that goes from jet fuel to the propane. This is the exact same propane that I was talking about before. So now Kaki's a much happier soldier. He's nimbler, he's lighter, he's more agile. Furthermore, propane in the battlefield now means you can use it for heating and cooking as well. And then finally, you can also contribute to your silent power production from your vehicles. So it's very versatile. Our core team is composed of 4 chemical engineers, and our scientific credibility is anchored by this good-looking guy on the left, Dr. Joachim Lauterbach, who commands over 20 years of R&D, as well as $10 million in research funding. In fact, this project started with a $1.2 million grant from DARPA, And we recently won the Fuel Cell Challenge, which we used to develop our LLC and then actually produce our first prototype. Now, I understand that for chemical engineers isn't the best horse to bet on when it comes to a startup company. So to that end, we're bringing on an advisory board who we're using to help us with our legal advising, our IP strategy, as well as our business planning. I'm not allowed to disclose who the fourth person is that we're bringing on because we haven't finished our negotiations quite yet. But needless to say, he has 20 years of startup experience and over $40 million of capital raised for his technology development companies as well. Our go-to-market strategy starts with the technology. We have a host of unfair advantages. First of all, our chemistry is very simple, right? We only require fuel and air. Our competitors require water, which can sometimes be more valuable than fuel itself in the field. They also require oxygen, nitrogen, and hydrogen, which are obviously unavailable if you're a military soldier. Our catalyst is durable, it can endure multiple cycles of reactions, and it's very efficient. In fact, the military's minimum requirements is 5% conversion. That's how painful this is for them. And we do it at 50%, 10 times. Finally, our catalyst is flexible. So tonight I'm talking to you about jet fuel, but it turns out it works for diesel, gasoline, and kerosene too. So all of these fuels can be reformed down to propane. With our technology, we're currently in the process of negotiating an exclusive license from the university. We'll take this exclusive license and turn around to our a strategic partner who we can team up with. We're currently speaking with 4 entities on this fund. All 4 of them have developed fuel cells. All 4 of them have sold products into the military market, and all 4 of them have the know-how to develop and commercialize our particular technology. Once we've identified a strategic partner that we want to work with, our revenue generation comes in the forms of sub-licensing fees, consulting fees, as well as royalties on sales. And we plan to start selling items in the latter half of 2014. Our revenue generation would then be reinvested into our company, and we'd be looking at expanding our markets outside of the military realm. So I want to bring it back to Kaki. If you remember, he was carrying 50 pounds into the battlefield. And with our technology, he's going to be much lighter, much happier, and much more effective as a soldier. But we can think about other people who are operating in the same space, right? So the Philippines, think about disaster relief crews. Or maybe, refugee camps in Syria. Or what about the tornado-stricken area in the Midwest? All of these crews come in with gasoline and diesel, and they typically don't have access to fuels. So with our technology, we'll help. Thank you. Yes, we have. In fact, so that's why DARPA initially funded this project with $1.2 million. And that's how we got the stipulation for what kind of performance achievements we need, technical achievements we need to achieve. So when you talk to customers, depends on who you're specifically speaking about. Users know we have not thought, but customers for our company, we're an IP company, right? So our customers would be these strategic partners who would take our licensing and develop the product with us. So when we speak to customers, yes, we recently went to a seminar, and that's how we actually connected with these 4 entities. We made somewhat of a splash. They're very interested in developing our technology with their fuel cells devices.
Aaron.
I didn't see any dollars behind any of this, so like, just put in something, I don't work with the military, I don't know about fuel transit. Like, what's a gallon of jet fuel cost versus a gallon of propane, and what's your catalyst cost for that?
Yeah, so I can give you more macroscopic numbers. Okay. So an auxiliary power unit will sell for on the order of $10,000 to $60,000, depends on the power output. We estimate that it will cost about $600 to produce our prototype in mass. Furthermore, we know that when you deal with the military, what they'll do is they'll build in your costs and allow you to take a 10 to 50% profit. And so when we talk to our strategic partners, first of all, our cost of technological know-how and our licensing is built into their cost. And so what we can do is take a fraction of their 10%, say, look, we bring half of the value to your product, so we want a 5% royalty on your sales.
Greg.
Did I understand you correct? Is USC on the IP?
Yes, that's correct.
How's that going to negotiate that?
It's going well. We've actually already entered a exclusive license option agreement. We've executed that, and so the negotiations for the license itself is beginning this week.
What's the term on that?
Even if I did know, I don't know if I'd be able to say it.
Right.
So you have this dust, right?
Yes.
And you mix the dust with fuel. That turns into propane, which you can then use to power stove, all kind of stuff, or the fuel cell.
That's right.
Is that right?
That's right.
All right. So do you have to build a conversion plant, or I can see how it works with a gallon of gas. What happens when you have 1 million gallons? I mean, how do you have to build like a plant to mix it and convert it?
So if you're in, again, if you're a forward operation, right, you're not shipping in a plant, you're not shipping in millions of gallons. So in a typical 3-day mission, you're gonna have several gallons, tens of gallons maybe, and you want to device something on the size of, a dorm
So
room.
this is a little portable for me.
It can be. So it can be scaled to whatever size application you may need to supply. So for example, if you're on a Humvee, it can be larger and they can have more throughput. But if you want to have it